Welcome to the lesson that explains the difference between greatest common factor, GCF, and least common multiple, LCM. We've already talked about the 3 steps it takes to identify the greatest common factor between sets of numbers. You list all your factors, identify common factors, and then from that list, you're able to identify the greatest common factor. Least common multiple is just simply 2 steps. You list your multiples by skip counting, and then you identify the least common multiple, which means the very first number that you come to that they share. That'll be the LCM. So I created 2 scenarios to give examples, and we split the page because a lot of students are getting them confused. They're wanting to list their multiples for greatest common factors, and that's not the way this works. Greatest common factors are the little guys that you multiply together to get the bigger product. LCM is the one that increases as you go, kind of like the multiplication chart. And that might be one way to think about it. If you think about the old-fashioned multiplication chart, which looks like this one, see how they increase in size as you go along? The skip counting, those are your multiples, okay? So if I go to Walmart and I decide I'm going to go ahead and buy some sweets to put into a box to give as Christmas treats, I might buy 36 cupcakes and I might buy 2 dozen cookies. 2 dozen cookies is 24 because it's 12 to make a dozen. So now I need to find all of the factors that create 36 and all of the factors that create 24. And I created my list and I identified the ones that they shared to find 12 is going to be the greatest common factor between the 2 numbers of 36 and 24. Now, 12 has a significant meaning depending on how the word problem is given to you. If it says how many boxes of treats can this person make, then the answer would be 12. But then sometimes they ask a secondary question. They'll say, well, in those 12 boxes, how many cupcakes and how many cookies would be in each box? Well, that's easy to figure out. Just look at the other factor. There would be 3 cupcakes and 2 cookies in each box. And then that was the rest of it. You always answer things, word problems in word answers, and GCF is 12, so I can make 12 gift boxes, and each box will contain 3 cupcakes and 2 cookies. We also created a scenario for LCM, which is least common multiple, and we decided that Khalil was going to work out, and he lifted weights every 3rd day, and he rode the bicycle every 2nd day. So we just skip counted by 3 and by 2, and the first number they shared was 6. Now, this was an event, the type of an event when both weightlifting was going to happen and bicycling was going to happen. So every 6 days, Khalil was going to have to ride the bicycle and lift weights. And so that would mean like on day 12, you could skip count by 6s to find out which days in the future would he be doing both activities. And of course, the LCM was 6, and we said every 6 days, Khalil will do both bike ride and lift weights because we did want to answer the problem in a complete sentence. Now, there's other task cards that I had that we presented to the students, and they had to decide whether it was using the greatest common factor method to solve the problem or whether it was going to be using the LCM method to solve the problem. And here's the first task card. It's not focused. Lisa is making activity baskets to donate to charity. She has 12 coloring books, 28 markers, and 36 crayons. What's the greatest number of baskets that she can make if each type of toy is equally distributed among the baskets? Okay, now here's that secondary question. How many of each supply will go into each basket? So you're going to take 12 and run all your factors, 28, run all your factors, 36, run all your factors, and find out what the greatest common factor is. Then you're going to use the other factor to answer the secondary question. So this is definitely a greatest common factor type problem. Here's another one. 2 neon signs were turned on at the same time. Both signs blink as they're turned on. One sign blinks every 9 seconds. The other sign blinks every 15 seconds. In how many seconds will they blink together again? Now, this is not a greatest common factor problem. This is an event. They're looking for something to occur. And anytime you're looking for something to occur, it's an event. So therefore, you're going to skip count by 9, skip count by 15, and use the LCM to solve this problem. Here's another one. The school cafeteria serves tacos every 6th day and cheeseburgers every 8th day. If tacos and cheeseburgers are both on today's menu, how many days will it be before they are both on the menu again? I'll give you a second to think. You can even pause the video and think and answer the question yourself. Is this a GCF problem, grouping, or is this an LCM problem looking for an event? Pause the video. If you said that this is an event waiting to happen, you would be correct. I would use least common multiple to solve this problem. Here's another task card. Joanne is campaigning for class president and plans to distribute some campaign materials. The campaign materials are 20 flyers and 18 buttons. She wants each classroom to receive an identical set of campaign materials without any materials left over. What is the greatest number of classrooms that Joanne can distribute materials to? I'll give you a second and pause the video. Think about it. If you said that this is greatest common factor, a type problem where you're looking to group things, you would be correct. You would list the factors of 20, list the factors of 18, and use the greatest common factor would be how many classrooms that she could distribute materials to. Good job. Another problem. Mandy is making emergency prepared kits to share with her friends. She has 48 bottles of water and 36 cans of food, which she would like to distribute equally among the kits with nothing left over. What's the greatest number of kits Mandy can make? Uh-oh, here comes that secondary question. Each kit contains how many bottles of water and how many cans of food? I'll give you a second, pause the video. If you said greatest common factor, because she's grouping things into boxes, you would be correct. And then you would use the other factor to answer the secondary question. So I hope that that helps you identify which kind of word problems that we can be given and which method you need to solve those word problems. There's one other thing I wanted to go over before I stop this video. Let me get the book out. There was a problem students were having trouble with. Yes, I am still there, staying logged in the call. Okay. Like, this is on page 31 in the book, and this is part of your homework. It says Monique is making gift baskets using the types of muffins shown in the table. Blueberry, chocolate, and strawberry. She's definitely grouping these into separate gift baskets. If you're grouping this, then this is a greatest common factor problem. You're going to Get the factors of 40, 48, and 32 and find out what the greatest common factor is. And then it just asks the one question: how many gift baskets can she make? Number 2, you are still dividing equally into separate groups. It specifically says groups. That's definitely a greatest common factor problem. 3 through 8, those are definitely just greatest common factor problem. Now, when you get to these bigger numbers, I would go back to using a factor tree. And I wouldn't want to list all the factors for 264 and 132. I would use the factor tree to help me. Number 9 and number 10, those are definitely going to be events. And anytime I see numbers written out cardinally, which means fourth, it's a cardinal designation, on every 4th visit to the hair salon and then every 10th visit of the hair salon, you would skip count by 4 and skip count by 10 to see where that next event is going to happen, where the person is going to receive both the discount and the free product at the same time. A bus line arrives at the certain bus stop every 25 minutes and every 15 minutes. Again, this is waiting for that event to happen. So you're going to skip count by 25s and 15s until you get to that first number that they share, least common multiple. And then number 11 through 16, those are definitely least common multiples. Just skip count by those numbers until you find the one they share. Now, 32, on page 32, these are definitely, my book is falling apart. These are definitely application problems, okay? Now, let me explain how this works. 17, the table shows the number of each type of cookie that a bakery has left at the end of the day. The baker wants to make the greatest number of cookie boxes to sell. Again, if you're grouping something into a box or a basket, it's greatest common factor. So if all of the chocolate chip and sugar cookies are distributed evenly amongst the boxes, okay, so you're not even talking about oatmeal raisin and peanut butter. You're talking about just 26 and just 39. So you are going to get the factors for 26 and 39 and find what the greatest common factor is. That will tell you how much the baker can put together in his boxes. And then you need to multiply that by $5 per box because he wants to sell them for $5 per box. And how much money will he make? And then you'll get your answer that way. It is the same exact thing for the notebooks, except you need to do, you're looking for an event, right? The notebooks come in packages of 6 and the pencils come in packages of 10. And the question wants to know, the teacher wants to have exactly the same amount of pencils as notebooks. So when something like that is asked of you, you have to skip count by 6, skip count by 10 until you get to the least common multiple. And then you need to figure out, okay, well, let me just go ahead and tell you. The least common multiple of this is going to be 30. So if notebooks come in packages of 6 and you have to buy 30 of them because 10 and 6, they have the least common multiple of 30, I'm going to go over here and ask myself, okay, well, how many sets of 6 do I have in 30? Well, I know that that's 5 sets of 6 because 5 times 6 gives me 30. And then I'm going to go over here to the chart and say, well, if I need 5 packages at $5 each, that's going to be $25 because 5 packages times $5 is $25. And then 3 packages of pencils because I need 30, right? Least common multiple is 30. 3 packages of pencils, and if pencils are $2 a piece, well, 3 times 2 is going to give me $6. So $6 to the $25, I add those two together, and that gives me the total amount of money that the teacher is going to spend on notebooks and pencils. And I hope that that homework explanation helps you solve these problems. Thank you for watching.